Hey guys, very good evening, and let's continue with the next part. So in the last few classes, we have talked about load balancers, right? And I take this class already in very detail, right? And we talk about four different load balancers we have in AWS. This is a classic load balancer, right? And application load balancer. One is NLB, network load balancer, and one is gateway load balancer, right? And almost all the load balancer guys we have discussed in detail with their use cases. Okay, and I explain you how we configure and how we're gonna use this, right? So all these things plus proper architecture also. It is not always that we have to only use ALB. Okay, sometimes we have to use ALB and NLB together uh, to set up this, right, to show some of the environment. So today's plan guys, we are going to start a new topic. Okay, and the topic name is called auto scaling group. Okay, so that is a topic we plan for today, auto scaling group. So what I mean by this, right, what is use of this topic? So till date guys, what we have done, if you just forget this topic for a while, okay, what we have done, we have a client, okay, and client is trying to interact with our server, and the better practice I told you, always try to send the traffic of the client via load balancer. Okay, maybe initially you might have one single instance that is called EC2, having one web server we have. Okay, so that my client will connect to the web server by load balancer. But why will go via load balancer? Maybe I explain you the concept. Maybe at that point in time we have just a startup company, and we believe that there will be not hundreds and thousands clients gonna come up to access our website. Let's say one website can handle 100 connections per second, and we know there's not huge traffic load gonna come up in this application. Okay, but as a proactive plan, okay, because we might be growing growing company, and there's a possibility, and mostly there's always possibility, okay, that the traffic gonna increase or client gonna increase. Okay, in this context I started by this setup. Why this setup? Because my load balancer is there. I will give this one public IP with the port number to the client. So client will only remember my IP address or my port number to connect. But behind the scene, my traffic has been proxied or routed to my actual backend servers. But why I go for this setup? That's what I'm trying to again explain you. But in my last class, I already explained this concept to you. One of the reason is if the more client gonna come up, let's say in a second, more than 200-300 clients or connections per second gonna come up, one single server won't able to handle. Okay, so in this case, what can we do without changing the IP address and the port number and updating the client that we are going to launch more server? We can add multiple server behind this. We can add one more multiple system. We can do it. We can connect. So I can launch one more instance. Let's say this A, same copy I can launch one more time, same copy I can launch one more time, and connect and register the server with the load balancer as a backend service. So my client doesn't have any visibility. Okay, they will again keep on coming same IP and same port number, but load balancer will balance the load. Some traffic will go here, some traffic will go here, and some traffic will go here. So that's what guys I explained in my load balancer classes. But in this case, okay, we as a cloud admins or the IT guys, what we are doing here, okay, we are monitoring our servers, okay, or maybe we are monitoring our traffic on the server. Okay, and what we are checking, let's say as per our understanding, we have checked that my server, the maximum traffic they handle, let's say, is 100 connections per second. Okay, let's say this is the information that somehow we collected. And there's a lot of performance oriented tool or benchmarking tool available in the market through which we can check that your respective server can handle how many connections per second. Or maybe system guys, you have a RAM. Okay, maybe you have given 8 GB RAM to the server, but we can check by some kind of performance tool that if your RAM is consumed over 6 GB or over 90%, the applications doesn't behave properly. They become slow and doesn't behave properly and doesn't properly give the response to the client, or maybe they're very slow. Okay, or maybe some of my performance team or the benchmarking team means they will set the benchmark. They check if system has some CPU, and if your load of CPU go above 80%, the application become very slow. Or maybe they check about the network bandwidth and say if your network bandwidth is consumed over 60% in and out traffic, right, our network becomes slow and all the client will face the network issues. So these are the factors we collected. How? By some of our team related to IT or networking or performance team or performance monitoring team, they collect these informations. So these are the benchmark information they collected by some kind of tool or by doing some testing on the tool or stress testing, hundreds of things we can do to collect this information. Okay, it means let's say initially we have one single server running, server number A. Okay, and this is the information we have. Okay, and this information, let's say we have as a cloud engineers. Okay, cloud engineers, we have this information over here. Okay, and what we do, we keep on monitoring our server to check does we are getting a connection above 100 second connection per second. Does my RAM the utilization go above 90%? Okay, does this one happen? So my cloud engineer will keep on checking this information. This is called monitoring. And why they monitoring? Because they keep on checking if any of these happen. What guys, one more please. I'm so sorry guys. I don't know why I forgot to share my screen. So I think a lot of things you have to lose, but technically this was let me again explain you. Okay, I don't know why I forgot to share the screen, but yeah. So this is a load balancer. We have 4 load balancer guys we have discussed, and today the plan is auto scaling group. That's what we'll see in a minute. Okay, and what I'm trying to show you, this is what the last example what I have still explained in my last class. Okay, when the client hit to the load balancer, I will give a fixed IP and port number to the client. As the plan initially with startup, we only launch one single instance. Let's say A, one single instance. Okay, and by why we put the load balancer? Because we never know in the future when the load increase, I might have launched one more computer and one more computer to balance the load. That's what we have discussed in the load balancing classes. Okay, and for this, we are the cloud engineers, and our duty is to keep on monitoring. And why to monitor? Because we have to launch one more computer to balance the load. Or maybe if the load increase more, we have to launch one more computer, one, maybe hundreds and thousands of computers we have to launch. And for this, we as a cloud engineer or as a human being or admin guys, we should have some kind of parameter with us or some kind of metrics with us. Okay, that might be given by some performance team. And they say one system, the resources, the way you have given the resources, one system might handle 100 connections per second, or might not work about 90% RAM been consumed, or if the CPU go above 80%, application goes down, or if network bandwidth become 60%, everything goes down as a network speed and data get and post, maybe, or the data to put. So this information is just giving a hypothetical number, right? So some of my team, they give this kind of metrics or the parameter to you, to whom, maybe let's say cloud engineer, or who are managing the load balancers for you. Why they give this information to this cloud engineer? So they keep on monitoring the system, and whenever any of the parameter, anything happen, that the RAM goes above 90%. Okay, in this case, they feel if RAM is above 90% being utilized, okay, then application becomes slow, so client will face the difficulties in the application. In this case, our cloud engineer manually go and launch one instance. The first step, that is manually done, and second step is they restore this instance to this particular load balancer. The second step they will do. After they do, now behind the load balancer we have two instances running, and now this is the by default duty of the load balancer to balance the load. So any of the issue come of RAM or CPU, that to be managed. Okay, and that is the reason why we need a load balancer. But adding one computer, again my cloud engineer has to now monitor two computers together, monitor two computers together, and if they see if all computers RAM and CPU again hit above this benchmark, okay, they have to launch one more computer. How? Again manually. But launching guys computers here or adding instances here behind the scene load balancer is known as scaling. And here we are doing a scaling manually. Okay, manually. But guys, again, manual thing is not good. You guys know. Okay, maybe you are launch your app, the app goes viral, suddenly viral at 2 o'clock or 3 o'clock. Maybe my team might not be so much active that point in time. Suddenly huge traffic come up, 1,000 clients come up to access your applications, but that point in time you have one system running, or my engineers is not active, they're not monitoring, maybe that point in time, or maybe some point in time, or maybe in the weekend, for example. Okay, in this case, okay, if any of the metrics hit or parameter hit, application goes down and client won't see and access your application properly. Even though we have the load balancer, but who going to launch one more computer? Who is going to scale my my computers? Who are going to scale and adding more issued instances? Because there is nobody manually monitoring, or there is nobody available here to manually add the computers or scale the computers or scale the instances. Okay, and that is a very, very critical issue. Again, to overcome this issue, what can we do? I want this exactly same infrastructure as a load increase based upon my parameter. Okay, this parameter more or less, but based on the parameter, I want to scale more computers to balance the load, so traffic, my client will see the better performance. Okay, only thing what I want to do, instead I depend on my team or my engineers or the human being, or I depend on the manual thing. I want the scaling to be automated. That's what we are looking for. Okay, and to do scaling automated, okay, we have one component, or we have one service in AWS, and that is called auto scaling group, ASG. So auto scaling group is one component or the sub-service of EC2, I can say. Okay, that has a capability to auto scale the thing. It means whatever your human being is doing, what they're doing, first they are monitoring what is happening. Okay, second thing, they are monitoring with respect to the parameter that is most known as metrics. Metrics means, if your, for example, if my laptop right now in my laptop I have 16 GB RAM, for example. Okay, but my this task manager in my Windows is keep on monitoring and to say at this point in time 52% of the RAM has been used. So my current memory utilization in my system is 52%. So this is called metrics. So metrics is 52% of memory. 70% of my CPU is being used right now. 1% of disk is being used right now. That much of my Wi-Fi or network card is being used right now. So checking your current status of your hardware or your resources. Okay, and there's more things we can do with other things also. Okay, are known as metrics. So my current memory utilization, if you want to know, that is known as current memory utilization metrics. In my case, right now is 52%. Is going up and down every second, every millisecond also. Okay, so rather than my engineers or human beings is keep on monitoring or monitor the metrics, okay, we ask auto scaling group, they will do for us. How? Automate it. Okay, and then we'll ask them, okay, that you are monitoring the metrics, okay, but I'm going to tell you some rule, and the rule is if my RAM goes above 90%, then do something. If my CPU goes above 80%, then do something. Okay, I will tell the rule, and based on the rule, they will do something. And mostly, what they do, mostly we will ask them to scale. Okay, so when this rule hit, okay, then they will do the third thing, and what they do, mostly they will launch the issued instances and add behind the load balancer. It will be anything other things also. I'll give you some more examples sometime. Okay, so typically whatever human being is doing, they monitoring manually, but here I want this monitoring to be automated. Then based on my other team, they given this rule or information that if you have this metrics and above this, then thing will go down or slow down maybe, or might not behave properly. So this information they have, so they keep on checking the rule, what they monitor against them. Okay, and whenever they find that your RAM is about 90%, for example, then they will manually go and launch the EC2 instance or scale the computer and maybe put behind the load balancer. This third thing they will do. I want all these three things to be automated, and this is the duty of your auto scaling group. Auto scaling group is the one who will do for you. Okay. Only thing that auto scaling group won't do for you. Auto scaling group is a one service. Their duty is to auto scale, means launch the computers and put in the load balancer when this rule hit. Okay, but only thing that auto scaling group can't do, they don't know how to monitor. Okay, they don't know how to monitor. And for monitoring, we have a one dedicated service available in AWS, and that is very powerful service. Always with any other service, this service we always use. Okay, and that's the name of service called CloudWatch. So CloudWatch is an independent service. I'll take a dedicated class on the CloudWatch. Hundreds of things they have to be discussed in the CloudWatch. But CloudWatch has one of the capability is to monitor the metrics. Metric is the RAM utilization, CPU utilization, something like this. They have this capability. Okay, so in this example, if I just try to recreate this example one more time to give this clarity, what we are going to do. So what I have one web server running in EC2. Okay, I want somebody keep on monitoring this instance. What they monitor? The current RAM, current CPU, current hard disk, IO, throughput, hundreds more things you can monitor. Okay, so you want to monitor the metrics. So metrics monitoring we would like to do. Okay, and I want this metric monitoring to be done automatically. Means we don't want to manually go and check the commands of Linux and Windows and check ourselves. Okay, instead, what I want some tool will do for us automatically, and the name of that tool is called CloudWatch. Again, this is one of the things CloudWatch can do, even though CloudWatch has some more capabilities. In my next class or next to next classes, I will talk dedicated on the CloudWatch. We'll see that remaining capabilities and more capabilities of the CloudWatch. Okay, so CloudWatch is a service that has a capability to keep on monitoring your instances. Okay, and after they retrieve the information, Okay, for example, let's say this RAM is been used. Let's say 50% RAM has been used. So CloudWatch will retrieve this information and say the RAM, the utilization right now in the system at this point in time is 55%. This information that it. Now, who want to use this information? That will be your choice. So we have a lot of services in AWS. We have, okay, these services can contact to CloudWatch and say, can you give me some information about the live infrastructure? Let's say about these instances. Okay, so one of that service that normally and mostly depend upon the CloudWatch is auto scaling group. Is the one like this. There's hundreds of the other services in AWS. They're very much dependent on CloudWatch. So in the CloudWatch class, I will talk more about this. But auto scaling group is one service. They say, CloudWatch, I just want to keep on giving this information to you about this instance that right now in my real time, the memory that is being utilized is let's say 50%. Just keep on giving this information to me. Why? Because somebody, the cloud engineers, has written a rule on me, write a rule on me. Okay, and the rule would be that just keep on checking this instance number, let's say A, or this instance ID, let's say A, and when my memory utilization goes above or equals to 90%. If this rule match, then do something. Okay, what to do? Okay, depend upon my cloud engineer what they want me to do. Okay, one thing they might want me to do when this go above 90%, then in this case, do one thing. In this case, do one thing. Send an email to my admin department or SMS to my admin department. That's called notifications. Okay, that's called notification. This is one thing you can do. Okay, in this case, we have a different service in AWS. This is called SNS. Okay, simple notification service. This service has capability to send SMS and email. So ASG is one service who can contact this service and they send the notifications. Okay, or maybe other things. There's a possible they might contact to some IoT devices and ask them to buzz the alarm, let the lights and LEDs. Might not be so much useful, but maybe some cases in some security to give a more way to alert things, they might contact IoT devices. So we have a green grass kind of service, or maybe other services in AWS that has a way to manage the IoT devices. Or maybe what we can do, if this memory go about 90%, then I can ask AAZ, do one thing, contact to EC2 services and launch one more instance of the same copy. Okay, or same copy of A. Means you guys know whenever you launch the instance, we'll use the AMI. So we can ask them use the same AMI and launch exactly same copy. And after this instance launch, then after this, restore this instance to this load balancer. Okay, as a backend server. As the backend server. Launch one more as a backend server. One more as a backend server. Okay, like this, hundreds more things we can do. Okay, so what action you want to perform? These are the actions. Any one action, any two actions you can perform depending upon your requirement. Okay, let's can hold for a second, please. So based upon the rule, who create, we cloud engineer had to create only once actually. Okay, based upon this rule and say when this will go above this. Okay, so 90% we decide. Okay, who decide? Cloud engineer. From where this 90% come up, maybe you or maybe my other team member, performance team can find out that if your applications go above 90% RAM utilization, they become slow. So they have a performance tool or benchmarking tool. They give this information to you. Okay, so this number come from here. Who give? Your performance team give this information to you. Where this information come from? This information is keep on coming in the real time from a service called CloudWatch. They give this. It means if my current RAM go above 91%, 92% is my instances, this rule match. And if this rule match, I will do these things. Any two, send the message, launch one instance, any two, all the actions we can, or any of the actions we can perform. Okay, or I can say whenever this rule match, we will trigger this action. Who trigger? Auto scaling group as a program. How? Automatically, based on this. So finally, what happened? Let's say this instance is going on running right now, right? Let's say this maybe one load balancer we have that has been registered with the load balancer, and if this instance is 51%, then it's go to 60%, maybe RAM go up to 80%. My CloudWatch is keep on sending this information to ASG. ASG say no, my rule is this rule match, no. 80% go more than 90%, no. It means I won't do anything. Okay, I won't trigger anything. I won't do any action automatically. But let's say this RAM after some time go above 91%. Live monitoring is done by CloudWatch. They send this information to ASG. Okay, or maybe I can say ASG is the one who's picking the information from there. Almost same kind of thing, right? For understanding. And if now let's say memories had become 91%, this rule match, it means something critical there. That's what my cloud engineer architecture planned, and they auto trigger. They launch these actions, any of these actions, or two or three of these actions, and they launch one instance from the AMI. Same way, why? Because I want to do load balancer, and for balancing the load, I need both the A and B should be same copy. Okay. They launch one and the rest are launch. So that is called, guys, auto scaling. Now, this is the process of happening auto scaling. So again, very quick revision. If you have load come up, you put load balancer, and for this you scale 1, 2, 3, 4, 10 computers. Okay, that was manual here. But in our case, same thing is going to happen, but it will be automatically, pure automatically. So scaling will be happen automatically. Okay. In this case, after B launch, then I keep on monitoring this guy also. So I'm monitoring the RAM of this guy. I'm also monitoring, let's say, monitoring the RAM of this guy. Okay. Again, same rule apply. Let's say by writing the rule, we are checking the memory utilization as average. Okay. If both the guys average goes over 90%, then we can launch one more computer. One more computer has been launched. Computer number B, C. Then let's say this guy is using 40%. At this point in time, again 3 is running, scale automatically happen. We are checking the average of all 3, and all 3 average goes about 90%. Again, we launch one more computer we launch. So we can keep on scaling again and again. So idea is very simple. If client is coming, that's good thing for our business, right? So I don't want to restrict the client. I want, as the client come up, okay, they will be properly served. So auto scaling will be help us to automate this thing. But there's a possibility more and more client come up, more and more computers going to launch, and more computers you launch, more and more cost you have to bear. So your company might have the budget on the cost. Okay, and based on budget, you say no, maybe more can come up, but I won't invest more than 10 computers. Okay, where you can set a max limit, and say if my auto scaling launch more than and try to launch more than 10 computer, I won't allow. Maximum computer that I am going to allow is to launch 10. Maybe after then more load gonna come up. Maybe my all client connections become slower down. That's a different point. But I can't bear more than 10 computer as a budget or the cost. So I want to set a maximum limit to 10. Depend upon the budgets and depend upon other reasons also. You can set the max limit also in the auto scale. Okay, that's what we can do. And in scaling world, I told you in the last class also, scaling means if one computer add one more, add one more, add one more, add one more, it's called scaling. Okay, this scaling is not a scale out. Scale out. It's not scale up. Scale up is a different concept, guys. So don't be confused. Scale up. If you have one computer, if you have 8 GB RAM, in same computer, if you increase the RAM, let's say 4 more GB. In one single computer, if you want to add resources, in the one single computer, this is called scale up. Okay, but if one computer running, if you launch one more computer, this is called scale out. Okay, but if you remove the computer, terminate the computer, it's also scaling, but this scaling is not a scale in. Scaling. Okay. But in the one computer, if let's say total RAM is 4.812, but if you decrease the RAM and you, after all, you make the RAM 2 GB, for example, this could scale down. Scale down, scale up in one single computer. So any resource, if you add and remove in one single computer, scale up and scale down. But if you launch more computer, let's say like a parallel 1, 2, 3, 4, 5, scale out, remove. In this area is called scale in. Scaling. Now in this example, right here, right now in this in our example, we are talking more about scale out and scale in. Okay, so there is a requirement. For example, there's one computer is keep on running. We add one more. More load come up. We add one more. It's called scale out. Okay, but we can create one more rule and say maybe not load is not coming continuously, right? They come for 1 hour, 2 hour, full day, half day. Okay, till the load come up, I keep on paying the amount for the resources, because if you launch more computer, more amount you have to pay. But I can ask my auto scaling group to do one thing, create one more rule. A rule would be as load decrease. Okay, if you think only 2 computers can handle the load, so then terminate this OS. Terminate this OS. Only run 2 computers. Okay, just keep on checking the load. If you think a load can be managed by 2 computers, terminate the remaining part. So it will save our cost. So automatically do scale in. So here the rule, guys, I was talking about, we can create both the rules. Okay, rule when to do scale out means add more computer when the RAM goes about 90%, for example, or CPU go about, let's say, 70% or something like this. Okay, at the same time, we can create one more rule, and the rule would be of scale in, when to terminate the resources, restored instances. The rule would be something like this: if my RAM goes less than equals to, let's say, 60% average. In this case, I can remove 1 computer, maybe 2 computers. Okay, so we can do scale in, means let me use the word remove the EC2 instances. And here I'm going to add a EC2 instances, for example. Okay, so we can create a rule for both sides, because this doesn't make any sense, right? Because the managing and balancing the cost is also very important. So we can create both the rules over here. Okay, and we can set the maximum limit. Okay, or we can do one more thing here. Okay, because guys, when you plan for the infrastructure, mostly the setup is not like this. We have a load balancer, and we always, it's not like this, we always launch for one single instance. Typically, at least minimum 2 computers we always run. Okay, 2 computers we always run. Okay, maybe 3 we always run. Always run. Okay, and that is a maybe let's say typical use case. Okay, maybe one computer running in one A data center, one is running one B data center, one is running in one C data center, something like this. You guys know because of the high availability of your disaster recovery or your data centers failing part. Okay, so I can say when I do a scale in, okay, maybe initially I will go maximum to 10, but this computer is not the resources is not is free, then decrease to 9, then decrease to 7, then 6, but minimum I want not less than 3. 3 I always want to give, even the load we have or we don't have the load we have we can increase, but even though we have no load, minimum computer I always need 3. So we can set the minimum limit also. Minimum limit 3. Okay, or I can use one more term here. Okay, in any of the cases, okay, I want, my desire is 3. I always want 3 computer to run. So there's one more term, guys, that is not actually equal. There's some difference. I will tell you the difference, but almost equals to minimum. This is for desire, but there's some difference. We'll see in some example in some time, maybe tomorrow. Okay, this is called limit. So there's 3 limit, guys, we can set here. Minimum, desire, like right now for some time, they think it is like a almost equal, but there's some difference. Okay, so minimum we can set or desire we can set as the 3. Okay, in any of the cases in the scale n means terminating phase, don't go beyond 3. Minimum run 3 at least always. But if you keep on scaling, this is called scale out. Sometimes only scaling. Keep on scaling till maximum 10, won't go beyond this. One of the big reason is mostly the cost. Other reason maybe sometime we have a lot of attacks happen. Okay, we know in any of the cases we won't get more than 10 computers. If something goes about 10, it means some attack is going on. So there's no making to unwanted waste the time. That so my security team will have better time to just check the issues. But by the meantime, don't increase more. Okay, so it will unwanted increase the cost of the infrastructure at a company. Okay, that is also one of the reasons why we always want to set the maximum limit. Okay, so this is some of the terminology I have given to you and the very interesting use cases and what the process of auto scaling group. Okay, to do more and more in the auto scaling group, right? You should be great in CloudWatch. So I'm not discussing CloudWatch right now. Maybe tomorrow I might take this topic, and then we'll add more advanced thing in the auto scaling group in tomorrow. But today, let me at least use the auto scaling group at the basic level. Okay, so this is guys the entire process and the architecture. Okay, so so let's continue with the practical of the auto scaling group. In the simple line as summary, if you want to launch multiple computers without manually, you want to launch automated without any human being, then the use of auto scaling concept come in play. That is simple, very simple line for auto scaling. Okay, so let's go and launch this. I'm going to use the AWS cloud. Okay, and in AWS, what I'm doing right now. Okay, right now we are guys running with these 4 instances. In my case right now, and in the last class, guys, I have created one load balancer already. Okay, name is the application load balancer. In this load balancer, right now, if you see the detail in this load balancer, right, Right now, if you see the listeners, so this load balancer guys is connected to my what I say the target group. Okay, if I click on this target group, in this target group, even though let me check, in this target group we have connected two targets. Two targets is been connected. Right now they're not using, but there are two targets been connected. Okay, so that was guys we have done. So right now what I'm going to do this is what the guys last spectacle we have. Okay, so what I'm going to do, even though let me do this spectacle very quickly one more time from initial, so otherwise you will might sometimes be confused. So what I'm going to do before the auto scaling group, okay, before the auto scaling group, what I'm going to do, I'm going to set up my load balancer. So I can connect my auto scaling group with the load balancer. So I'm going to set up one auto scaling group. Sorry, application load balancer. Okay, and you guys know any client come to autos application load balancer, they will always connect to the target group. Okay, so traffic will be sent to the target group that you guys we have discussed in the ALB classes. And in target group, you have one computer, two computer, three computer. Based on the computer, they will balance the load. Okay, that's what guys you know till now. Okay, now what I'm going to do till date, these computers launched by us. How? Manually. And this computer has been attached and registered to this target group by us. How? Manually. Okay. Now today what I'm going to do, okay, I'm not going to launch any computer by myself, and I'm not going to connect these instances to the target group by myself. I want this to be done automatically. And who will do for me? My auto scaling group. So right now the practical will be something like this. Okay. Right now I'm going to launch a empty kind of target group. Let's say target group would be named, let's say, my target group. In this target group, there will be no instances of EC2. Okay. And I'm going to launch one load balancer called, application load balancer that will be connected to target group. And I say here in my application load balancer, any traffic come to you to any of the URL, any of the route path, send here. Okay, from the obviously from the client. But any client hit to application load balancer, yeah, they send to target group, and target group we have no instances, so obviously finally error gonna come. Okay, then I will go and launch the instances. But in this case, I am going to launch the instances with the help of auto scaling group, not manually. Okay, so at least first create the setup. This will be again the quick revision of my last class also of ALB, right? So what I'm going to do, I'm going to create first target group. We'll talk about auto scaling in some minute. I'm going to launch a new target group here where I'm going to add computers, okay, to this one. Let's say my target group. Okay, everything same. I'm changing my VPC. This is the VPC guys we had created. I'm using that VPC. Okay, and health check is same, no change. Let me decrease the health threshold for 2, and let me decrease my interval, let's say to 5, or maybe timeout to let's say 4. Okay, that's what guys we discussed already in very detail. Okay, and here in this target group, I'm not going to register any of the computers. Okay, this computer will be automatically registered. That's what I want to see. Okay, so there is no target in this target group. Is empty. Okay, so this target group, what I created right now, okay, is have no targets. So it is like a blank, blank. Okay. Only thing I'm going to do, I'm going to attach this target to my ALB. So ALB is not yet attached. So let me create one ALB here, load balancer. Okay, application load balancer I'm going to create here. Let's say my ALB for auto. Okay. Again, internet facing, put into same VPC. Okay, and I'm putting the ALB into my public subnet. Let me add one more ALB for auto scaling of the ALB public. Okay, security group, I'm giving allow my ALB, some kind of security group we created in the last class. Okay, and this is the port I'm using right now, port 80. And say anybody who come to ALB on port number 80, okay, I will set default action target group. I will set this traffic to this guy. Okay, so target will be my target. Okay, that's all. Anything else? No, and that's all. Now, this was a quick revision of my last class. Everything we discussed in last class, very, very detailed. Okay, so this is what guys auto scaling group is provisioned. In this case, if you see the target group, now this target group, my target group, sorry, my target group is kind to this ALB, but in this target group, we have no instances. So this setup, guys, is one-time setup. Either you can do it manually, or you can do with the AWS command line tool, or you can do with the Terraform. That will be your choice. One-time setup. Okay. But main thing is there is no instances, there is no computers here. We're going to launch this computer. I want that to be automated. Okay. So who will launch? That's what the auto scaling group come in play. But before this, let me check. This is still provisioning right now. When this guy launch, and then you click on your name or the DNS name, and when you hit, okay, that time you will see right now service 303 means the instance is still loading, is not been launched, is still provisioning, now active. Is active, right? Now if you hit enter, and what you see guys, this error come up. This error also means this load balancer is active. They're sending this traffic to this target group, but in this target group we have no instances we have right now. That is reason 543 error come up. This called service temporary unavailable. That means there is no computers behind the scene, the load balancers. Okay, now who is going to launch this computers? Auto scaling group. We can do it manually, but I want to be automated. So for this, we have to go for auto scaling group. Okay, so how can we do? So there is the concept called launch configuration and auto scaling group. First, we have to set up the launch configuration. Idea is very simple. Okay, I want this computer to be launched. How? Automatically. And if you want to launch any EC2 instances automatically, obviously you have to tell about these instances. That when AWS is going to launch this instance, what you want, which AMI you want to use, which instance type you want to use, and some more details. Okay, because this instance, if you launch manually, then we can select all the things, right, while launching the instance. But this instance is going to launch automatically, so you have to do and create this setup once. That is called, when you will launch this, what configuration we need, what configuration we have to use. So we have to set up this launch config again once. at only once initially. Okay, so we have to go and use launch configuration. I don't have right now. Let me create one. Let's say this is my launch configuration for my, let's say, for website. Okay, UNCH for website. Okay, so here what we have to say, whenever I want to launch the EC2, whenever I will use this configuration. Okay, I'm not going to launch right now, but whenever I want to launch, okay, I need this configuration. And when my auto scaling come in play. So when auto scaling want to launch one computer here, I will use this setup to launch. One more computer, I will use this setup to launch. One more computer, I will use this setup to launch. And every time I'm going to launch use same setup, then all the computer will be exact same configuration. That's what I want behind the load balancer, right? Same instances, the same AMI and same setup. Okay. So here I'm going to use the AMI. Let's say I'm going to use the AMI that is we created, or you can use other one also. This is what the AMI I created in my account. Which instance type? Okay, so I want to use the instance type. If they have T2 micro, I want to use this free one, T2 micro. Okay, this is what we can use. And do you want to add some IAM role? I don't need any other things, advanced details, any other details like RAM, other things, any hard disk extra, no. Any security group, maybe because these are the web server, so I want to use a pre-created security group. Let's say security will be allow web server. That's what I like to use. Okay, key pair if you want. I want to choose a key pair. What I have, let's say this one. That's all. So whenever auto scaling happen, I want this configuration to be used to launch this setup, or this and this. So one time configuration we are doing here, and this is for known as launch configuration we have set up here. Okay, this doesn't launch any computer right now. I'm just setting up this launch configuration. Okay, so this setup and this configuration has been done. Okay, they are not launching any computer. For example, if I go up to my instances right now in my computer, I have only four computers there, or one is running. I can say only one is running at this point in time. Okay, so this launch configuration only we are just setting the configuration part. When I want to do automated, this is what I need. Okay, but who will launch this launch configuration? Who will use this setup? Who will use this launch configuration? My auto scaling. Okay, now here the auto scaling makes sense. I will ask my auto scaling, okay, and say do one thing. Whenever you do auto scaling, use this launch configuration and launch the computer for you. And when you want to use, whenever anything triggers, and that I explained to you. So whenever I create a rule means when my memories goes about 90%, 80%, CPU go like this, hard disk I go about like this, something like this. When the rule match, okay, so who will check the rule? Auto scaling. So whenever the rule run and check conditions right, that's called that. In that case, you have to trigger this launch configuration and launch the computer first. Okay, so now guys, finally, what we have to do, we have to finally go and set up the auto scaling group, ASG, auto scaling. Okay, so auto scaling group is, that's what guys I explained to you. It's a collection instance that enable automatically. Okay, something like this. This is what I explained to you, and some of the example, you will see max size, min, desired. They are almost same. There's some difference. I'll discuss about the min and desired. Okay, and this could scale out as we need. You can do another facility also we have here. An example also we have here. Now in the auto scaling group, let me give the name first. Name my auto scaling group. Okay, think in this way. Now onward, instead my human being or my IT team is going to monitor the the um, the computers manually. Okay, this manual thing will be automated by Bespoke, and whenever something trigger, okay, then you use this launch template. Okay, I don't have a launch template. Okay, but there's some difference between launch template and the launch configuration. We have actually created a launch configuration. Okay, so what the difference I'll tell you in a minute, but let me switch to the launch configuration. Okay, so there's some difference, almost the same, but there's some difference between launch template and the launch configuration. We'll discuss, but right now in my case, I created a launch configuration. Okay, what difference I will tell you in some minute, or maybe in the next class. So actually we have created launch configuration. Okay, launch configuration we have created. So that's what I'm going to select here. Launch configuration. This is what we have created. Okay. So whenever this auto scaling group trigger, this launch configuration to be used according to this setup. Okay, my instance server will launch automatically. Okay. Next, network would be where you want to launch this instance, because they are not yet launched. It's going to launch in the future. So whenever the auto scaling group, okay, launch a new computer, this one, which VPC you want to launch. So I want to launch this guy into my VPC. Which AGs you want to use? I want to launch this guy into public or private. Let me launch in the private, as per way we have done in last class also. Mostly we put the computer behind the scene load balancer in private world. So this private AG I want to use. Okay, this private also, and sorry, there we have one more private. This private also. Two we can use. Why? Because I want a high availability. So my auto scaling group launch some instance in this private instance, some in this private instance. So because of my AG, sorry, my availability zones goes down, failure, we have other copy run in other computers. That's what the also I will explain in my last classes. Okay, click next. Advanced configuration. Do you want to launch these computers? Okay, these computers behind the without the load balancers. Maybe we can launch without load balancer also. There's some use cases where I want to launch more computers without load balancers. There's some specific use case for this. But according to our use case, I want to launch this behind the load balancer. Okay, so I want to launch behind the load balancer. Okay, so do you want to create a new load balancer? You can create it also from here, or you want to use connect the existing ones. In our case, my load balancer already exists, already created this. Okay. Now, which one you want to use, the older one or the newer one? Means ALB, NLB, GLB. I want to use the newer one. In the newer one, we have a concept target group. Target group is a part of newer one. In classical, we don't have any target group concept. So I have to put in the newer load balancer that I already created, and target group also be created. Which target group we have to use? So this is the target group we have created, my TG. I want to use this target group. It means my auto scaling group, when they launch the instance, they will launch in this target group. Okay. Health check. You want to do, for example, I'm not changing here. So by default, health check what they have, I'm going to use that one. Okay. Other things we want to discuss right now, but nothing very technical. It's CloudWatch. We'll talk about the CloudWatch in the future. Okay, here the scaling policy comes in play. Okay, means when you want to launch a computer, what is the maximum limit, minimum, or desire you have? So let me set 111 for all, just for a while. I don't want maximum have more than one, minimum one, and desire one. Okay, let me use one. Means whenever these auto scaling groups created, we asking my desire is one. That means whenever you create, just check, do you have any instance running? Any instance running here? Okay. If no, then my desire is one, at least one you have to launch. And that case, guys, because of this one, okay, you will see one computer automated launch as soon as you create this. So example, right now in my target group, in this target group, we have no computer, nothing is created. So we are asking in this target group, if you have 0, but I'm asking my desire is 1. So as soon as my auto scaling group created, because your desire is 1, means we are looking for, this is my desire and that is not there. So this will go and create 1 for us. Okay. Scaling policy, guys, I will talk about this concept in tomorrow class, but the way I explain to you this concept, CloudWatch, metrics, rules. So creating the rules, all those things has been come in the scaling policy. Right now, I'm not creating any rule. I'm going for by default with no rule. Means whatever setup I am writing here, that according to the setup will work. For example, if I write 3 will be launched. Okay, there's no rule. So this computer will launch automatically, but there's no policy. They are not going to use any CloudWatch to check the metrics. Okay, so that's what I'm doing. So I'm controlling my rule launches with the auto scaling right now. There's no rule checking or policy checking, but how to write a rule, I will discuss tomorrow. Okay, I'm going for by default now. Okay, and then click next. Okay, if you issue instance terminated launch, do you want to send any notification, SMS, that was I was talking about. Again, I'm not doing right now, but after SMS topic we'll learn and show you how to add this. Again, nothing very technical. Click next. This is a tag. Click next and this setup. Okay. According to this setup is a setup for auto scaling group, and auto scaling group says here, okay, you have configured me in a way that you said me your desire is 1. So I'll check your target group. If the computer is not running there, or computer or instance is not running there, anything, and your desire is 1. So this you guys called current status or current state. If your current state is 0 and your desired state is 1, okay, in this case means what I'm looking for is not there, so I will launch 1 for you automatically. You don't have to manually do it. That's what I will do for you. But how I launch, I need a configuration. So you have already given me the configuration, right? I will use this configuration to launch. Okay, and that's what. So when I click create according to my desire, so they're updating my capacity. Okay, updating my capacity here, and because our desire is 1, so in any of this availability zone, they are launching your instance according to a capacity. Right now they are launching, so only the instance is 1. Okay, but in some time, what you will see, okay, in your target group, 1 computer has been added in some time. Okay, plus in the EC2 also, you will see 1 computer launch in EC2. Okay, so behind this, they are launching in some time. After the launch, you will see it being launched. Okay, I think this is the one they launched right now, I believe. Okay, I think this is one they launched right now. Okay, behind this. So this instance, maybe they might have launched right now. Maybe. Okay, so this instance has been launched according to our plan, which we see with subnet. And as you can see, your autoscaling group name this one. So this instance is been launched by my autoscaling group. Okay, but if you see the other instances, guys, all other instances, guys, we have launched manually. So there is no autoscaling group name come up. Manually we have launched, but in this instance, okay, it's been launched by autoscaling group automatically. This name comes. And after they launch, they will add behind the scene in my target group of the load balancers. So you see here, they have been loaded here, it's been loaded automatically. One has been registered and been healthy because I had the health check. Okay. Now, if I go to my ALB, you can see this website is going to come. Fantastic, right? Working great. But this time, this instance come automatically and it's been completely managed by auto scaling group. One beautiful thing, guys, about the auto scaling group is because our desire is, let me refresh this page, because our desire is one, they launch one for us. Interesting thing, they keep on watching this. Due to any reason, if your instance is terminated, I manually guys terminate this instance. If instance terminated, okay, auto scaling group is keep on checking. Okay, and they find the instance terminated, okay, but your desire is one, they again relaunch one more new folder. So you see here in a minute, you see one more instance they're going to launch in some time. As soon as they see, because they keep on checking the health check, as they find the health is down, so the health is down, they remove from here, from your target group. Auto scaling will see that is been down. Okay, then they relaunch one new for you. So in some time you see, guys, automatically one more new gonna come up in some time. Again, guys, they're terminating after this. They have some kind of grace time also. That will also how to change. But in some time you'll see one automatically launch. Okay. Even though, guys, in the auto scaling group also, you can see the you can see these options also. For example, my desire is one. Okay, and if you see the activity, okay, activity, guys, is about the notification, but in the activity history, here you can see that right now, initially when you launched, I had 0, but because your desire was 1, so they've launched 1, 0 to 1. It's called scaling, auto scaling, scale out. But sometimes you'll see one more history come up. See here, they check the instance out of service in EC2, indicating you have been terminated or stop the instances. Now this information come in your auto scaling group automatically. Okay, and now in progress. In some time you will see they will launch one more. So one more history come up, and now what they say, I found you have 0 instances. Now we are increasing to 1. This is called pre-in service. Okay, that was successful, and your load balancer see your ALB connections has been drained out, means it's not able to connect. It looks like instance terminated or stopped. So they ask auto scaling group, because desire is 1, so launch one more. So pre-in service is going on, and sometime you will see there was successful, one more instance has been launched. Now, if you see here, one more new computer has been launched right now, and this has been launched again by auto scaling group, and that is the automated register to your target. And finally, if you hit enter, you will see again the new website. Okay, but maybe if you want, let me show you some more options here. instance refresh, that is again, that is not monitoring. That we will talk about the all the things was in some time, but yeah, instance manager. Let me show you some important things if I can show you. Yeah, this is what guys you can see. Okay, instances, one is in service and one is terminated. When I launched terminated, that's also come up here, and service also been visible here. Okay, but let's say in detail of this instances we have one desire, but let me edit this and let me increase my desire to 2 or let's say 3. Okay, now I'm asking that my total desire is 3. I want my auto scaling is keep on checking, and if they don't have 3, they will launch 3 for me. Update. But obvious guys, okay, if desire is 3, you want 3, but you won't go more than maximum, right? So you do say maximum at least 3. Maximum means right now guys I'm launching by setting these values, but tomorrow guys when I test with the CloudWatch, so as the more RAM you use, they launch one more. So let's say you can set I can't go more than 10. Okay, so whatever desire would be means desire means when I set up the issue instances, I want always 3. But desire obviously can't be more than maximum. Okay, so that's what the warning is. Now you set your desired 3, okay, and they're updating your capacity. So automatically they're launching total 2 more or total 3 they're trying to make. And in this case, if you see your activity of auto scaling group in the history, okay, and that is they say now you change your limit constraints here, and you're asking for 3, right now is 1, so I'm doing auto scaling for you. It's called scale out. Okay, and trying to make a difference of real, current, and desire. Current is 1 and desire is 3. I'm doing scale out for you. And now in the issue, automatically 3 total 2 more instances, but total 3 is going to launch here. 1, 2, 3, 1, 2, or maybe 1 more. Maybe they're launching. Okay, and as soon as they launch, that is being registered here. See, one more they are also launching behind the scene in some time. They've also been registered here. Okay, and now if you do the auto scaling, load balancer means load balancing, load balance. By chance, both those has same data, but Intel you guys also know behind this, and I explained in my last class, they are doing load balancing to one and to other. Okay, so that is the whole idea. Now 3 has been launched. Now this has been launched. Keep on running 3. Good thing is, due to any of the reason, if one of my computer goes down, instance goes down, okay, maybe let me stop in this case, not the terminate. Your auto scaling group will restart this guy or maybe create a new one. Okay, but they make sure it should be always 3. Okay, when used, the target stopped. When sometimes you see this will again connect because your desired is 3. So they make sure the instance total running at any point in time would be always 3. Okay, so this is some of the vocabulary I explained to you about the auto scaling group and the launch configuration. But this will make more interesting when this thing to be automated. This is automated only, but automated means now this will be done by checking the rules, the metrics. For this, I have to first explain you CloudWatch, and after I explain the CloudWatch, then we will connect this rule in the auto scaling group. Setup will be almost the same. There was some extra attribute I will add, okay, of the CloudWatch and the rules here, and that will be as soon the network goes down or above this bandwidth or RAM CPU. That's why I'll explain to you. So this launching new and adding new will be more makes sense. Now this one is first deregistering Okay, because this is goes down. So from auto scaling group, the target is re-registering. This is called draining also. Okay, and after draining, because my DJI is 3, then they will launch one more here. This is called registration. So one more new instance, right? They launch and they're registering here. Everything is automated. You don't have to worry about that. Okay, so powerful service. So typically, this is the way we always use, right? So automatic launching the instance is done by launch configuration, right? Design and checking the rule done by auto scaling group. Everything put in the target group. Load balancing is done by ALB. Network performance loading is done by NLB. And above this, we have DNS. All those components connect together and have a powerful setup. That's what typically the architecture in the real world also. Okay, so that's all, guys. We'll continue this topic. This topic is not yet complete. We'll continue this topic tomorrow. Any query if you have, you guys can ask. No, Rajsekhar, discussing on the Datadog doesn't make any sense. It's a different tool altogether. But we'll come up this kind of tool training also, like Datadog, New Relic, Splunk, App Dynamics, the different training. You guys can join there. Okay. So any query, guys, if you have, you can ask me. Yes, Rasu, I will talk about launch temporal also, and plus the difference also. What is different minimum design difference also in my tomorrow class. Okay. Yes, Raghu, we can integrate with Prometheus also. Not in this class, but if you are the part of my Prometheus training, I will tell you how to integrate the metrics monitoring of AWS with the Prometheus in my Prometheus class. No, Avinish, auto scaling and load balancer are not the same job. Right? Load balancer is to balancing the load of the computers to the computer, I can say. But who will launch the computers automatically is done by auto scaling. Okay. How the monitoring of load balancer work? I think I told you, Pooja, already in very detail. Now, when you're this diagram when I show to you, right? I explain in very detail. Okay, this process is been done by CloudWatch. Okay, this demo I'm going to show you in tomorrow class. You will see practical way also. Okay, but the process of monitoring is done via CloudWatch. That's what I explained to you. But tomorrow I show this particular demo in my tomorrow class. So, Sudhakar, in my last class, I had discussed in very detailed discussion on ALB and LLB. Plus, I saw the demos also, right, of ALB and LLB in my last classes. So, horizontal scaling and horizontal scaling both. No, Omkar, adding more and more computers is called horizontal scaling. If you do it manually, that is normally known as horizontal scaling. But if computer added automatically, then it is mostly known as horizontal auto scale. But typically, we don't use this bigger word. We always use the word called auto scale. So when we say auto scaling, it means computer is adding, okay, in the horizontal way. But only difference, what you're asking, is manual and auto. A brief on adding EC2 configure OS to my AMI. Nothing, Prashant. My AMI is the AMI we already created in my initial classes in this training only, where I show how to create our own AMIs. Okay, so that was I explained you. So I keep on using AMI. Otherwise, if you use the blank AMI or raw AMI, you do always configure the web server for testing. Okay, that was the only reason. Thank you so much, sir. Your teaching of VPC and detailed console helped me interview for British company. That was very nice. Big trend. Congress from my side. Person, I explained you already. A load balancer is sending the traffic to load to backend server, right? Via the reverse proxy concept I explained in my initial classes. That's how it works. Okay. Why there is no security group in NLB? If you see the NLB here, okay, let me show you the load balancer. Okay, this is what the NLB guys we have created. Okay, NLB we have created, and guys, if you try to see in the NLB, we have no security groups. Okay, there is no firewalls. If you see anywhere, you won't find any security group in an LLB. Okay, but if you go, very interesting question, actually somebody asked me, what you asked me guys, but if you see any other load balancer like ALB, in ALB guys we have security groups. Okay, why? Because NLB guys is very highly performant for network traffic. So what NLB do actually behind the scene? Okay, any other load balancers, the client is actually connecting to the load balancer. Load balancer take the request, create a new session, okay, and send to the target computers like EC2. Any other load balancer like ALB, CLB, other guys. Okay, so it means for the client perspective, they are connecting the ALB or create a session to the ALB. Okay, send to ALB and sending all the application data to ALB. ALB is one who is checking all the application layers or data at the ALB side and creating new connections and to the send EC2. So for the EC2 perspective, traffic is coming for ALB. So ALB is a client for EC2. That is the reason, guys, in the security group of EC2, we allow the IP for ALB. When the ALB, we have a separate security group that where we allow the IP of clients. Okay, because client perspective, guys, they are connecting to ALB. They think the ALB is a real server. And that reason we have a security group in the ALB. This is what I explained to you. But in NLB, guys, you know what happened? Okay, NLB work and the network layer, they don't have a capability to create sessions or don't have a capability to check the application headers. Okay, so any traffic come from the client. Okay, NLB is mostly work like a router, not a proxy server. Any traffic come, they send as it is to the EC2 instance without checking any application header or session in the passenger layer of OSI layer. They are not creating any session. It means NLB is not working as a proxy or reverse proxy for you, the way I explained you in my last classes about other load balancers. Okay, it means any traffic come from the client, the as it is send it. Only difference between router here is they have capability to load balancing. There's extra things what router doesn't do for you as such. So any traffic come up, as it is, they send to this client, next they send this one, like a load balancer. But here they are not reading any application headers. Okay, that is the reason. That is the reason, right? Means they are not creating any session to the client. As it is, they are sending the packet to the issued instance. That is the reason there is no meaning of the security group in the NLB. And that is the reason, guys. Okay, this issued instance should have a capability to connect from outside world. So in this issued instances, we have to properly write a security group for the client. So in issued instance, guys, if the security group is blocking the client request from outside world, they won't be able to connect. Okay, won't be able to connect. Okay, but this design is not the right design. So it's not advisable to connect issued instance directly to NLB. Okay, Otherwise, a lot of issue come up. It means any instance running in the private world won't able to connect. The client is actually directly connecting to EC2 instance. So any instance running in the private world won't able to connect. And every EC2 instance in this world should have allow all the access of internet the way you normally use a normal instances. That is the reason. Okay, this diagram is not at all advisable, and that is the reason, guys. This is not at all usable diagram. The diagram that is right diagram is what I explained you, and this is what the tactical we did. So the setup would be client is connected to NLB. NLB, behind the NLB we have ALB, and then we have instances. No, this kind of diagram I explained to you. Okay, so in this case, client is coming to NLP and they're sending request here or here and here without checking their application headers, without creating a connection as a proxy connections. So there's no use of security group. It means client is directly connected to ALB. So client field, they directly connect to ALB. And that is the reason, guys, here in the ALB, we are allowing all the clients. Okay. And because they're not checking any application header or they're not creating any sessions, that is one of the reasons why NLB is super faster and having very low latency. Okay. And that is the reason, guys, in NLB, we don't have any, any security group implemented. Okay, so what good? I think socially you asked me this question. Thank you very much for this, for asking this great question, so that everybody can get the idea what external we will do for you. Egress only, Pooja, we will definitely discuss in my upcoming class. There's some small topics there in VPC. Intentionally, I skip this topic because some of the topic has some basic requirement of load balancer. So I thought first to cover this. When again go back to VPC, this egress only and some more concept like a transit gateway, those things we'll discuss in upcoming classes. Okay. So how you research deeply, we'll definitely discuss plans in that way. Okay, guys, see you tomorrow with some more concept of auto scaling group and the cloud merge. Bye, take care, see you. Good and good night. Take the class on integration of pen drive with AWS. This is, I think, one of the tasks I have given you. I will definitely give the hint in my upcoming classes, okay, to you how to integrate your local pen drive to the AWS cloud. Okay, but this is one task I think I have given you in my initial classes. Okay, so that's all, guys. See you tomorrow with some more concept. Bye, take care. Good night.